Good morning. My name is Shafiq Rehman, and the topic of this webinar is cybersecurity, security requirements engineering for the system, where I explain how to determine security requirements for a system and also especially for cyber-physical systems. Cybersecurity is very important topic nowadays, as cybersecurity breaches are happening to the largest and most technological advanced organizations, and unfortunately they are becoming ever more sophisticated. This has been accelerated by COVID-19 and by a remote workforce with access to sensitive company data. Global workforces are using multiple end devices and connections through networks, and often they are unsecured. Cybersecurity experts have continuously warned organizations around the world to take preventive measures to avoid damage to their operations and reputations. So, a small introduction about myself. My PhD is from University of Duisburg-Essen, and my master is from Technical University of Dresden. I have around 20 years of experience in different organizations. And since September 2021, I'm working with sepp.med as a consultant requirements engineer. These are the contents of my today topic. First, I give a small introductions and focus on importance of security requirements and security requirements engineering. Then I explain cyber-physical systems and security of cyber-physical systems. Then I will also go through our proposed security requirement engineering framework for cyber-physical systems and the evolution of proposed framework. And at the end, I conclude my work. So we live in the century of industrializations where humans rely on technology. We do our daily tasks with the help of technology. We do shopping online. We make online payment. Even we control many devices with the help of technology. So in this pandemic situations, organizations grow increasingly. They depend on technology, and without technology, they cannot survive and compete the world. But on the other hand, organizations are very curious about security. We regularly come across their security concern like password stolen, identity theft, and systems are infected by viruses and worms. Websites are unavailable due to denial of service attack, and many others. So the cost of information security breaches keeps increasing from thousands of dollars to millions of dollars. So modern society and current economy have to rely on technology, infrastructure for transportations, energy, and finance. Cyber physical systems are gaining much attention for practitioners, experts, and researchers due to their high impact on world economy. And these systems are considered as a hallmark of the computing power. Cyber attacks are increasing continuously from spam, phishing, and also much larger scale. There is a real possibility that cyber attacks could bring down power grids. They can disable command systems, paralyze communications between the systems, and so on. So integrating security requirements right at the beginning not only ensures secure software, but it also saves precious time and reduce effort of rework of the software development team. And on the other hand, ignoring security requirements may cause the product to be failure, costly for maintenance, and very difficult to manage at later stages of software development. So early acknowledgement of security allow to predict threats and their consequences before a system is in place. And the importance of security is widely accepted. Different studies shows that cyber threats have increased, and there is a need to do more research to systematically handle the security requirements. And the cost of poor security requirements shows that even a small improvement in this area would provide a high return value. So since the world is moving towards secure systems, security has become a primary concern not an afterthought process. Many organizations still think security is an afterthought process, but organizations have to understand that security is not an afterthought process, but a very important factor in the requirement engineering phase. If we see in this simple example, the manager asks, did you fix all of the security flaws? And the answer is no, because there is no way to know. There is no checklist, there is no, that security requirements have been not identified. So in this case, it's very hard to fix all of the security flaws at the end. So security requirement, basically the aim of security requirements engineering is to avoid security threats and vulnerability in the software and throughout the software development lifecycle. And security requirement is necessary for effective evaluation for success and failure of the system. Software security engineering proposes many tools, techniques, methods, and best practices, but there is a lack of understanding of security threats and their vulnerabilities. Organizations are not very successful to develop a secure system without applying a framework. However, there are a number of methodologies proposed for secure software development, but still there is a need to improve those methodologies. So basically, security is a protections from harm, and also to unauthorized people cannot view the private informations. And security requirements are defined as constraint on the function of the system, and these constraints operationalize one or more security goals. Security goals such as confidentiality, and this information should not be disclosed, the private information, to any unauthorized person. Integrity, the information should be accurate and trustworthy, and availability. The system should be available when needed. For example, the system shall not display customer personal information to other organizations, or the system shall provide personal information only to members of HR department. So I come to cyber-physical system. Basically, cyber-physical systems are systems of systems that merge the physical world with the world of informations processing. And cyber-physical system basically consists of mainly three layers: physical layer, network layer, and application layer. The physical layer consists of sensors, actuators, sync node, gateways, and many other components. And they are all tightly coupled and integrated with the physical processor. Cyber-physical systems include huge complex systems like smart grid, infrastructure of transportations, smart cities, smart buildings, and others. And the environment of cyber-physical system is complex and different, as they automatically adopt the current environment according to their situations, which create the complexity of the system. Typically, they have large infrastructure, which creates the complexity of the system, and they work on a distributed environment. Since many cyber-physical systems depend on sensor network, their security is an important factor. Extra attention needs to be given on a physical layer, since this layer is more vulnerable to attack. And the security of cyber-physical systems to protect the components CPS from malicious attack, unauthorized access, or damage to physical part. Because the sensors are located in open and accessible area, which are more vulnerable to attack. Also, they have very complex interdependencies and crossover effects, which also lead to unexpected threats and vulnerability. And in physical layer, sensors are subject to strong security critical constraints because they have limited resources, processing power, they have limited memory space, and also limited battery power. And physical attack might damage or compromise the system. If you see in this example, sensor read the information from the environment and pass to sync node, and for further processing, it goes to process controller. Here I explain few threats in physical side only. So there is a possibility that attacker could divert the data to any unknown place. And the attacker can also place hot or cold objects to prevent the information from the environment. Natural disaster is a natural event like heavy rain, heavy snow falling, hurricane, earthquake, and so on. The attacker can also damage the sensor, or there is also possibility for vandalism. So therefore we need to protect all those in physical side especially. And the popular example of cyber physical attacks are Stuxnet, Marucci waste management system, Ukrainian power grid. So the question is how to protect security. So do we need secure cybersecurity mechanism like authentications, encryptions, firewalls, antiviruses, and so on? But is it sufficient if we apply all those methods? Because interactions between cyber and physical system make control system different from classical software systems. And malicious actions can enter anywhere in the closed loophole and cause harm whether channels are secure or not. And we also know that hackers are very smart. They always try to find a loophole and try to find vulnerability to exploit the systems. So therefore, we need a better security. In this case, I will explain. This is one way that we have to identify the security requirements. So at the end, we have a at least checklist so we can evaluate the systems in respect of security. So the proposed framework is a systematic process to elicit the security requirement, and it consists of a set of essential activities required to elicit the security requirements. And it aims to serve as a complete guideline. The detailed process helps for practitioners, research and to working towards determining the security requirements for cyber physical system. And here, every activity basically contribute to elicit the security requirements. And the proposed framework consists of main three components. First is analysis of CPS environment, security requirement engineering activities, and we use one technique called misuse case. Misuse case is the inverse of a use case, a function that the system should not work. So the purpose of first component is to analyze the system environment. The CPS environment is an important component that influences the understanding of the system. And in order to identify the CPS environment, aspects in the system operational and physical context are analyzed. The analysis of CPS environment begins with use cases for the system. Use cases give the system function requirements which help in designing the initial high-level CPS architecture. The architecture also gives us an idea about the components of the CPS. The external environment, that is context with and the relationship between the two. After analyzing the system environment, we perform the framework activities. The framework is in the form of iterative. We continue to proceed and refine until we arrive at a reasonably sufficient understanding of the CPS environment. So the first activity in our second component is to identify assets. Basically, asset could be anything that has value for the organizations. It could be employee, money, software, hardware, server, or any other camera, for example. And we have to identify all assets in three layers: physical layer, network layer, application layer. For all, this is applicable for all other activities. And our second activity is to identify security goals. And security goals mainly refer to confidentiality, a limit of access of informations, integrity, the information should be accurate, and availability. And the third activity is to identify threats. And the purpose of this activity is to identify the threats of all three layers. We also categorize in application, network, and physical layer. Threats are basically analyzed with the help of misuse case. And the fourth activity is to identify the secure network communications protocols. Wireless sensor network devices need to be properly authenticated also in the network domain and deploy security and protocol like TLS, IP security, and so on. And the fifth activity is to identify the endpoint hardware. So failures of hardware endpoint will also lead to disruption of cyber-physical system components, which not only interrupt the operation but also lead to vulnerability and open avenues for the attacker to thread any CPS devices. Our sixth activity is to identify sensor types and their communications medium, M2M machines protocols, sensor routing protocols. And a seventh activity is the purpose of this activity is to evaluate the level of risk, where a risk can be seen as the value of expected loss to an asset due to a given threat. And we also develop risk assessment metrics in this case. Once we have all previous 7 activities, then it becomes easier to elicit the security requirements. And especially threats and security requirements are helped. Misuse case basically help to analyze the threats and also analyze and identify the security requirements. So here I explained, we also develop a framework workflow process. The workflow process basically helps to apply the framework activities, and the workflow process is a set of guidelines which involve a sequence of activities used the analyst practitioners to identify the security requirement. And the workflow process is best worked out by the security advisors, the team of requirements analysts, and other stakeholders who are involved in the project. And the framework basically is in the form of checklist. For every activity, there is an input, technique, and output. For example, for identify assets, we have architectures. Also, we have a generic checklist of assets where we can identify and apply techniques like use cases, facilitating meeting sessions, and get the output. Similarly, once we have an output, it's easy to to identify the security goals. And the output list of CPS assets becomes the input of activity 2. And also we have a checklist of detailed security goals. And technique where, for example, facilitate meeting sessions, we can also conduct interview, and we get the list of security goals. So this is the whole process, and we complete until we identify the security requirements. I also basically give one example how we apply the framework and how we identify the basically security requirement for cyber-physical system. The proposed framework is evaluated by applying into 2 case studies. The first is a smart car parking system, where we develop a functional prototype and apply our framework. And the second is soccer watch systems, where we apply the framework in a real-world scenario. Soccer watch basically is a company, and they place a very HD camera in the middle of the ground, and they provide a live streaming for football matches. And once we analyze the systems by applying our first component analysis of CPS component into 3 layers, we are able to design a high-level architecture. And also we design an architecture into 3 layers: application layer, network layer, and physical layer. In physical layer, we have a HD camera, and it consists of sensors, network SIM card, motor, and so on. All information provide to Vodafone base transceiver stations, and for further processing, it goes to local server, public cloud, and to the client side. So accordingly, I just one example how to analyze threats using misuse case. So in this scenario, we analyze threat also into 3 layers: physical layer, network layer, and application layer. If you see in this example, the attacker can damage, or also they apply laser light to exploit or delay the information through denial of service attack. And there is also a possibility of natural disaster. Natural disaster is a natural event like heavy rain, snow. They can also affect. So also in network layer, the attacker can have a man in the middle attack, for example, in the server side or SQL injections. And also in the applications layer, the attacker can also disclose the sensitive information for SolarWatch data, for example. They can also manipulate the data or tampering the data. So accordingly, we analyze all those threats in all those three layers. So basically, the tool is designed to export all the result from the 7 previous activities into one single file, which make the process of security requirement elicitations significantly easier. And once we have all those outputs in our framework, then we can easily identify the security requirements for SolarWatch. So here are the all outputs of our activities we apply. Assets we identify, security goals also, threats, secure network communications and hardware endpoints, sensor type and communications medium, and also we apply our risk assessment metrics. So I give one example, eliciting security requirements with misuse case. We know use cases are very popular technique to elicit the functional requirements. On the other hand, misuse case is also a good technique to elicit the security requirements. And meeting sessions through scenarios like misuse case is a most suitable method to elicit the security requirements. And misuse case also facilitate for the understanding and communications between team and the stakeholders. The industry survey also shows that scenarios are the most suitable method to determine and validate the requirements that make agreed and consistent. So similarly, we apply also misuse case in, I just give one example, in physical layer. The attacker can also have a denial of service attack through laser light, for example, or they can also damage or theft the camera. And we also identify the security goals, which is availability. Because if there is any denial of service attack, there is affected for availability live streaming. So similarly, we analyze through misuse case and we are able to identify the security requirements. For example, security requirement 1, the system shall ensure that the HD camera shall be protected against physical damages. And also through this information, the system shall ensure that the HD camera should be protected against theft. And we also add more details. The assembly must be kept that its case can only be accessible to open through specific keys. Also, no screw or nut shall be provided to be opened easily. And security requirement 6, the system shall prevent denial of service attack, for example, in this case, laser light, or any remote malicious attempt on camera. And also security requirement 7, we identify through this analysis of physical layer, the system shall ensure that the HD camera should not be sensible against extra light, like laser light. So by applying same methodology on physical layer, network layer, and applications layer, we are eligible to identify 42 security requirements for SolarWatch. In physical layer, we identify 22 and focus more, and also in network layer, few of them, and applications layer. So now I conclude my work. Cyber physical systems are an emerging field, and also cyber physical systems are going through a revolutionary stage in their development. Therefore face many challenges, and security is one of the challenge. And the cybersecurity itself is a very broad domain, And therefore, we have to focus one aspect, which is security requirements. And our proposed framework is a comprehensive security requirement engineering framework, and it supports the elicitation of security requirements, and it also provides a complete guidelines through a number of activities that I explained, 8 activities, and it also contribute to secure the whole system, contribute to secure the systems, hence minimize the economic and life-threatening situations. And we evaluate the framework by applying into 2 case studies. The first is a smart car parking system, and in a smart car parking system, we also identify more than 70 security requirements. And the increased demand of security in organizations also justify the need for systematic development of a framework. These are the references that I used in my presentation. So thank you very much. If you have any questions, you can ask me, and you can also write your feedback on this following email.
Questions from the webinar audience. What about self-organizing systems and security for Industry 4.0?
Yes, actually, there are Industry 4.0, the technology we use, cyber-physical system, IoT. Security still is I can say, is a main topic to do more research. And cybersecurity is a very vast domain. So here I explain one aspect, one factor, which is security requirements. And the problem is, again, how to determine the security requirements, especially for Industry 4.0, because they all using their physical environments and network layer and applications layer. So this is a point. So in this case, I just focus on security requirements. And once we have the Industry 4.0, the security requirements, it makes easier to implement all those security requirements, I mean security mechanism. So we can also discuss with the practitioner researchers and find out the possible solutions, because this is one aspect to determine the security requirements, and then we have to find the countermeasures for every security requirements. Once we find the countermeasures, then it becomes easier to implement those countermeasures, apply algorithms and so on. And at the end, it becomes more easier. Once we have the checklist of security requirements, we can check one by one, like functional requirements. So before it was too difficult if we don't have functional requirements to identify which functions we have implemented, which one not. But once we have functional requirements, then it becomes easier. Similarly, also in this case of security requirements.
You mentioned a generic list of assets. Are there more generic lists? Where are they available?
Actually, this was the research, and it is available in the Duisburg-Essen University Library. And yeah, hopefully, I think it's open. I'm not sure. And this is available.
Do you also have experience in testing software systems concerning security? Would you use the same method as for CPS?
Actually, at the moment, not. But we got experience by applying our framework by using 2 case studies. One, I said, we develop smart car parking systems. This was not a complete system, but a functional prototype. And there we applied and check all our activities, and also using misuse case. And the second case study was, as I said, Soccer Watch. It is a real world scenario, and we also had meetings with the representative of Soccer Watch. And I mean, the thing is that stakeholders should be involved, because if we talk about asset or security goals, there is a generic list. But once we talk and discuss, using misuse case is very helpful technique, because without this, it's really difficult to identify the security goals and assets, or also analyze the threats. So in my examples, we also analyze threats into 3 layers. This becomes more easier. So the main purpose of our framework is a complete guideline, and we have to apply one by one. Once we have the 7 activities, then it becomes easier to elicit the security requirements. Because otherwise there is no way. I mean, we cannot work on an ad hoc basis. This is a complete systematic process.
The number of security goals are affecting the whole assessment and in the end the extent of security requirements. Is there a help or guidance on finding proposals for these goals? And are there descriptions of what is behind these goals?
Actually, as I said, we have a generic list, but again, we have to discuss, we have to go in more depth to identify and describe those security goals. What is the purpose and how they affect? Otherwise, it's difficult. I mean, just applying or take from the checklist. The one benefit, we take all those security goals and apply and check what is the goal behind. Then it becomes easier. Otherwise, I mean, without analyze, so it's difficult. And because we have to go more in depth, so we cannot say more generically. Because for every, there is different domains. So we have to apply for every specific domain and provide the mechanism and descriptions for every security goal.
Is the used CPS a mirror or simulated environment, based on, respectively extracted from the real system or architecture?
For every domain, there would be different architecture. But for high level, we have to analyze the first CPS environment and also design the architecture into 3 layers: physical layer, network layer, and applications layer. So it should be different. It depends on the domain and also nature of the project, basically.
Did you consider BSI basic protection in your analysis?
Yes, we also checked these all standards, and these are just informations and guidelines. Yes.